relationship I have is 3x plus 2y equals 6. And I want to graph this now without not by plotting points, but by looking at its intercepts. So let's go ahead and find our x-intercept and our y-intercept. Remember, when we look for its x-intercept, which one becomes 0? Our x value or our y value? Well, when they're looking for our x-intercepts, our y value becomes 0. So 3x plus 2 times 0 equals 6. 3x equals 6. So I have an x-intercept of 2. Which is also the same thing as saying that it crosses the x-axis at 2. So I have the point 2 and 0. Its y-intercept is when its x value is 0. So 3 times 0 plus 2y equals 6. Solve that out. 2y equals 6. Remember, zeros are powerful. It wiped out an entire term again. Solve that through, y equals 3, which tells me its coordinate pair is the point 0 and 3. So I know it's two intercepts now, which are enough points for me to know where its graph is at. It crosses the x-intercept at 2, right there. Crosses the y-intercept, the y-axis at 3. And there I have 2 points, and 2 points is enough to draw and create a line. However, there's one small danger that could happen when I use this method. I have to make sure that I'm accurate on both intercepts, because if I made a mistake, I would have drawn 1 point in the incorrect spot, and therefore I would have created the wrong line. So sometimes it's not a bad idea to do a checkpoint. Just choose a number and see if that number also works itself out. So let's see what happens when x equals 1. So let's plug that into the equation. 3 times 1 plus 2y equals 6. 3 plus 2y equals 6. Subtract 3 from both sides. 2y equals 3. Divide both sides by 2. I get y equals 3 halves, or 1.5. So there's my checkpoint. I want to confirm that point looks like it's also on the line. So it's over 1 and up 1.5. And I see that my checkpoint is on the line, which gives me confidence that my intercepts were correct, and those intercepts allow me to choose the correct line.